Uh, Hi, students. So let's start with the problem number 3.12. Uh, this problem says the pipe flow in figure 3.12. So that's the figure 3.12. Fills a cylindrical tank. So this is the cylindrical tank as shown. At time t equals to 0, the water depth in the tank is 30 centimeters. So let's say this is the 30 centimeter, right? Initial condition 30 centimeter. Estimate the time required to fill the remainder of the tank. So let's say you see the whole height is 1 meter and this is 30 centimeter. That means 0.3 meter. So we still need to fill out with the 0.7 meter, right? So how long it will take to fill out this 0.7 meter height of this tank, and the tank diameter is given, right? And also, the water is flowing in this in this direction. You see the water flowing. Initial flow velocity is 2.5 meter per second, and the outlet velocity is 1.9 meter per second, and the diameter of this tube is given 12 centimeter. So whatever fluid is flowing in, through this condition in inlet is not going out, because you see that diameter is same, but the velocity is not same. This is higher than this is, right? So that means, whatever fluid is coming inside the system is not going out. So what happens is, like, some of this water is going up and increasing the height. And we need to, calculate the time that is required to fill out this tank. So how can we calculate it? If we think about this system, then whatever is coming out, it should go out, or there should be some accumulation. So this is the accumulation, right? Accumulation inside this tank. So that's the time derivative term, right? dy dt multiplied by rho dv. That's the mass flow rate, right? You divide by t, so it's mass flow rate. So that's the mass accumulation. Plus m out is the whatever mass flow rate is going out, and m in is the whatever mass is coming in. So they're basically whatever, if you put this in right side, that means whatever is coming in equals to accumulation plus whatever is going out. So that's this equation. Okay, now in this equation we need to change the dv. V equal basically the volume, right? So volume you can write pi r square h, right? Pi r square h. So you see the pi is constant, r is also constant. R is basically the radius of this diameter, right? So sorry, radius of this diameter. And h is not constant. As I said, initially the h in height was 0.3 meter, and then it should start increasing because we are flowing what that is going inside this tank, right? So the h is increasing. So if we put this v equals to pi r square h, then we should, and the rho is constant. There is no change in rho with time. So the rho, it should take out, come out, and pi r square, it will also come out. So rho pi r square multiplied by dh. So dv equals to now dh by dt plus, we can also replace this m out equals to rho av of out condition minus rho av in condition equals to 0. In net amount of fluid is 0, right? Now if we rearrange this equation, we should get like dh by dt equals to, so this should go on the right side and this should go also right side, this should divide. So it will look like 4 by 998. So basically the 998 is the rho, that means the density of water, then pi multiplied by r square. So r means, you see the d square by 4, right? That's why you see this 4. So d means 75 centimeter. So if you convert it to meters, it should be 0.75 square, right? Multiplied by these two terms. So at first this out and then in. So basically rho A is constant, right? Rho equals to 998 and A is the area. Now this area is actually this area, cross-sectional area, and that area, meaning this area, or radius, is basically the cross-sectional area of this tank. So be careful about. You see, out and in condition is actually basically these two conditions, and the accumulation condition is basically in this tank. Okay. So the rho is 998 multiplied by A equals to pi rs, r square by 4, right? So pi multiplied by r means radius. So here it's given the diameter 12 centimeters. So 0.12 square divided by 4 multiplied by V out minus V in. So V out is sorry, if we take out this right side, it should be V in minus V out. So V in equals to 2.5 minus V out equals to 1.9. Now, if you put all this information here, you should get the dH by dt equals to 0.0153 meter per second. So if you integrate on both sides, take this t on the right side and integrate both of them, you should get the t delta t value equals to 0.7 divided by 0.0153. That is 40 seconds. That means, yeah, it will take 40 seconds to fill out the tank.